Good afternoon, and thank you all for coming here. Hope you enjoyed your lunch. Welcome to Wait No More. Here comes Maven 4. And if you came here in the hope or in the expectation to see Maven 4 being released here live on stage, I'm sorry, I have to disappoint you. You can leave. I'll pretend I didn't see it. But if you are curious what Maven 4 will bring to you, whatever your role is, then please stay. I'm happy to introduce Robert Scholte to you, my co-speaker for today. Robert has been Apache Maven committer since we just discussed
2009.
2009, so that's quite a long way back. He's been in the project management committee, has even been chair of the PMC for a while. My name is Maarten Mulders. I've been working on Maven since roughly 2019, so that's 10 years less. And recently joined the PMC as well. So what are we going to do today? We are going to discuss a lot of stuff that's going to change in or with Maven 4. We will do this because we are short in time, without a single break, but instead we'll have two. So that means we have 3 blocks of an hour each, and by the end of each block we'll try to have some time for a little question or two. And we expect to have a little bit of time for questions at the end as well. Without further ado, we cannot discuss the why and the what of Maven 4 without looking back a little bit. And as I said, Robert has been working on Maven since 2009. So who else to discuss this than Robert himself?
Well, now I feel very old.
And you should.
I should? Okay. So a little bit about the Apache Maven history, and that's all because we want to explain why we went to the first major, why we go from Maven 3 to 4. There must be a huge thing underneath it to make sure that, well, to say that it is worth it. So let's go back to Maven 1. Who has been using Maven 1? Sorry about that. So I think Maven 1, it was the first version of Maven, but I think within a couple of months, years, they already noticed there are some issues with it, especially with the BOM file. So they made this brave decision to say, okay, we were going to remove everything and start from scratch. And then we had, in 2005, we started with Maven 2.0. So one of the main things is, like I said, the build file has changed, and also, and I didn't know that because I joined the Maven team around Maven 3.03. But they told me that in the first version of Maven, the plugins were bundled with it. And they separated that since Maven 2, which is quite important, of course, because now they have their own release cycle. Then, 5 years later, we decided to go for Maven 3. And the main reason to do that is actually under the hood. What they did is they took out the dependency resolution part. They called it Ether at that time. And they made it as a separate component. And that was the main driver to move to Maven 3. And as you can see, this was a jump from 1 year to 5 years, and we're still using Maven 3. We're currently at 3.9.9. And now we're waiting for Maven 4. But we don't know. It's an open source project. It's always, we're wondering when it will be. I did similar talks about this topic already before COVID. And then we didn't even have the first alpha and beta release. But I said, well, we have a branch about Maven 4, and this is what we're going to do. And that's what we're going to talk about, because now we have these alpha and beta releases. So I will give you the spotlight.
Thank you.
Now it's up to you.
I thought we were doing this together.
Yes? I will take the second part, okay?
Okay, that's great. Let's do that.
That's good to you.
Yeah, so, well, you already mentioned it, Maven 4 being an open source project, we don't have really a strong timeline, and the only thing we know for sure is that we will release it when it's ready. It's a bit of the Debian mantra that you probably am aware of. But there's a few things that we can say already about Maven 4, both in a lot of detail, which we will cover soon. But the highlight for you to take away is this. If you're using Maven 4, your existing projects should still be buildable. This is, of course, assuming that you can build them today. But I count on that, right? Just checking here. We're not fixing your build problems. Second thing is, it will continue to build, except you will probably see a few more warnings. Warnings about things that you are probably already doing wrong, but you have been ignoring so far. Because you either didn't know, or you did know but choose to ignore, which is valid. It's a free country, it works, you can do that. But we're going to be more explicit. This is probably not what you want. This is probably a potential problem. And some of these things will turn into errors in the next major release. But for that you have to wait no more, here comes Maven 5, except that doesn't rhyme, so we'll probably think of another title by then. So this is the takeaway for you. Your existing projects will work. You will probably see a few more warnings that do require action if you want to stay up to date with the version of Maven that you use. Well, what is Maven actually? From a bird's eye view, I would say Maven is a Java application. I hope this is not a surprise to most of you. A Java application that is also a plugin execution framework. Robert already mentioned it. The plugins are not bundled with Maven, they come separately. So Maven needs a way to resolve plugins and to actually execute parts of a plugin. This is also the key answer to a question that I frequently got: why is there no native executable of Maven? Why don't you guys just build it with GraalVM? It's awesome, it will start super fast. And yes, it will start super fast, it will also fail super fast, because at compile time you don't know yet which plugins, which versions and whatnot you need to run your build. And that is the requirement that GraalVM gives you. It must be known beforehand, all the components that you use to run your application. So it's a plugin execution framework with a specialization towards building other software. And finally, if people say Apache Maven, they often also refer to the, let's say, the core plugins, the plugins that ship, well, they don't ship with Maven, but they are maintained by the same people that also develop Maven. Technically, you could say the plugins are a different thing. They have a different release cycle, but in common speak, they're often referred to as the same thing. Now, being a Java application, an application typically takes input. And for Maven, this comes in the form of command line arguments. There has to be either a plugin goal or a lifecycle phase argument, except you can configure a default one in your POM, but we're not going to cover that today. And optionally, you can add a few flags. The second input is system properties and environment variables. Of course, there's pom.xml, the file that we all know and love or hate. And finally, there's settings.xml. And the output of Apache Maven, well, basically, it depends, because it depends on the plugins that you have in your POM. It depends on the lifecycle phase that you call.
This classic answer works always, right?
It's always the valid answer, indeed. It always depends. So, as a quick aside, you can always fire back on that and say, depends on what, and then we're back to answer that. So I've highlighted two things, the command line arguments and the pom.xml. Why? Because they will change with Maven 4. There are changes there that require some attention. So let's start with the first, the command line arguments. There are changes to be expected there, and we can divide them in 4 groups: success and failure conditions, profile and module activation, the reactor itself, and then a few other things that are either added or removed. Let's start with the first group, the failure-related stuff. As a plugin developer, a Maven plugin developer, I should say, You might be tempted to write code like this. Somewhere in your plugin, you have an execute method, and the method says log.error, not enough coffee. I don't know for you, but for me, that's a pretty common cause of failure. And you probably expect by then that your build will fail, right? It's an error after all. Surprise, surprise. Maven says, I'm fine with this. There's an error, there's not enough coffee, and the build is a success. How is that happening? When I first saw this, I was a little bit confused, but it turns out to fit perfectly well in Maven's philosophy. There's two motivations to change here. By default, the only way for a plugin to really fail the build is to throw an exception. And as we just saw, logging an error message will not fail your build. That's all fine, but you may have a different expectation. But secondly, and I think this is a more important one, warnings are typically there to identify a potential problem to you. They're not there because we as developers are like, yeah, it's not an error, but it's more than an info. So, well, let's meet in the middle, let's make it a warning. They're there to tell you this is probably wrong. This can fail, this can signal that you did maybe not understand what the argument was for, or why you should configure this or that. Or maybe it's not on your end, but it's, hey, files are not in an expected location, or they have a different format or whatnot. They signal that you need to take action, that you need to investigate the situation. And if you don't, then maybe it will become an error that you are aware of, or even worse, one that you are not aware of, and that slips into your build, goes into production, ships to your customers without you even knowing. And that's why we've introduced the fail on severity flag, which by default does not have a value and also does not trigger anything. But you can choose to add this flag to your Maven invocation, or even do that on default, and specify a log level that will actually cause your build to fail. So you can say fail on severity error, which means that as soon as somebody logs they don't have enough coffee to run the plugin, your build will fail, which to me, again, makes perfect sense. But you can also say, if there's a warning, I want to make the build fail. And maybe this is not something you want to change from one day to the other, but it's worth thinking about it for a minute. If I care about the stability of my build and the quality of what I build, it might make sense to activate this.
I got one question about that.
You have a question?
Can you also fail on info or debug?
If you want to.
So that means that actually the build will fail anyway.
Yes, but there's a quick way to do that.
Oh, tell me.
Just make a typo in your command line arguments.
Oh, yes.
Or I don't know.
Okay.
False.
False.
Most shells know that. Mm-hmm. But yes, you can. Second thing that changes when it comes to success and failure outcomes of your build is a subtle change in checksum verification. As we know, Maven can download plugins, dependencies, and all other things from the internet. I've often heard people saying, oh yeah, Maven, that's the tool that downloads the internet for you, which is in a way correct. They do it together with NPM though. But when we do download dependencies and plugins, Maven also checks, using a checksum file that lives at the repository server, if the artifact was retrieved intact, if there's not some kind of a transmission error. By default, in Maven 2 and Maven 3, if that would fail, you would see a warning. Remember what I just said about warnings? They are potentially errors, but you just don't know if you don't pay any attention. So that's why we make it more explicit in Maven 4. If this verification fails, we, by default, don't want to include that in a build. If the artifact is potentially corrupt, this may be a problem you want to investigate. Now, of course, there can be a situation where you are faced with a dependency that lives on Maven Central and the artifact has a wrong checksum published. Should not happen, but let's imagine for a minute it happened somehow. Well, in that case, you can suppress the check. There's -C or lax checksums if you really must, but please don't do this, because this checksum verification is supposed to tell you a message. You probably don't want to rely on these artifacts that you've downloaded.
So this happened to me, I think, a couple of times, that you build your project and you get this class not found exception, and you think, how is that possible? I'm pretty sure that it's in that jar file, and then it seems like that jar has been corrupted. So that's one of the main reasons why we say this should be done by default. But you could wonder, why not do that already with Maven 3 or Maven 2? Well, first of all, it is a big change, so I think you should choose a major version of Maven to do that. But also think about the first version of Maven Central. Yes, I'm going to back like over 10 years ago. I can tell that, right?
20 years even, I think.
Yes. So at that time, it was just an FTP server. So people were just pushing jars, whatever. Now we have artifact repository managers, and they make those checksum by default. So we now can assume that there are always checksums available, so we can check them.
And more importantly, that they are valid.
And that they are valid.
Because most repository servers require you to upload these files, but then also check that you did before publishing it. At least that's what happens at Maven Central. If you upload through Sonatype OSS, they will verify that you passed a checksum file and that the checksums match.
So this is really about historic reasons. We could not do that before because it was just not there.
Yeah.
And this is probably the best moment that we can do it. And we all want it because it gives you really, really weird bugs.
Yeah. The second part of command line arguments that have changed is about profile and module selection, or activation if you wish. Until now, if you use Maven and you try to activate a profile or a module that does not exist, it will fail the build. So whether you do -P code coverage or -P exclamation mark code coverage, which means activate the code coverage profile or deactivate the code coverage profile. If that profile does not exist for some reason, Maven will tell you it can't do what you asked it to do. Now, we are adding the option to say activate or deactivate this profile only if it exists. But if it does not exist, it's no problem, you can continue. And you might be wondering, why are you doing that? Because why activate a profile that doesn't even exist? Well, some of us work in companies where development and build pipelines are standardized, are out of their control, and then some platform team decides that you must have a code coverage profile because that is how we will measure your test coverage. And maybe you want to do that by default, maybe you don't want to adhere to what they ask you to, but right now it will require you to add a profile that does nothing, just to satisfy whatever it is, Jenkins or Azure DevOps or GitLab CI, because it expects the profile to be there. And with this change, you can say, yeah, sure, if it's there, we will activate it. If it's not there, we can move on without the platform team having to do a big change. They only have to add this question mark. So it means to deactivate or to activate only if it exists. And there's a nice extra add-on. I don't know how many people noticed, but the message that a profile doesn't exist would typically only be logged once at the start of the build. And now we will log it twice. Well, that was the change you've all been waiting for, I know it. But the reasoning is pretty simple, especially if you have larger builds. It doesn't make sense to have this original message, the requested optional profile could not be activated because it doesn't exist, to have it logged only at the top of the output, then have 10,000 lines of output, which nobody reads because they only look at the end and they say, oh yeah, build success. This might be a problem, so we want to make it a little bit more obvious to you as the end user. Hey, you tried to achieve something, and maybe it was intended to not work, but maybe it was not your intention. And in that case, please be advised that this profile didn't really exist.
Right. So with Maven 3, if the profile does not exist, Maven will just continue and will say, well, I don't know it. And for Maven 4, we thought, well, there's probably a reason why it was activated,
Exactly.
right? So if you just made a typo, especially if you're doing a release and you make a typo and something fails, it could be quite annoying to try to figure out what went wrong. And now we can say, okay, if you specify a profile that does not exist, just fail immediately, unless you use this question mark in front of it.
Unless it was on purpose.
Exactly.
And then we can continue, but we will inform you about
Yes.
this. Yes. And I hope you paid attention to the previous slide, because the same applies for projects. All right, the third thing that changed is all about the reactor. How many of you have any idea of what the reactor is?
I do.
You do? I'm not really surprised. I'm surprised you're not raising your hand, Karl-Heinz. Oh, you raised it before, thank you. So for those of you who didn't raise their hand or didn't dare to raise their hand, the reactor, you could say, is kind of the mental model that Maven maintains after it has loaded all your pom.xml files about the structure of your project. Which modules are there? How do these modules relate to one another? Which modules are a child or a parent of another module, and what dependencies are there between modules? And using this information, Maven will make a plan on the order in which all these modules will be built. It's not necessarily the order in which they appear in your project structure. Maven takes into account that if module C2 depends on module B, you need to build module B first, even if it would not have come first alphabetically, or first being declared. Now, there was a problem in the reactor in Maven 3, where resume from, a feature that was, I think, also introduced in Maven 3.
Yes.
Yes?
It was.
Well, it could work, but most of the times it did not. And to illustrate this, I have a sample project here. Module A is a module that only contains a few interfaces. Module B has an actual implementation of that module. And module C2 is actually the client application that uses both the implementation and the interface. And we will soon see why in Maven 3 that may give problems when it comes to resume from. Because in Maven 3, what would happen? If you would use the resume from flag, the first thing that the reactor would do is it would say, okay, apparently you want to resume the build from a given starting point. That's fine. Everything that comes before this module in this calculated order, I can forget about it. It's not relevant anymore. Drop it. Then it would try to build from wherever you specified you wanted the build to start. And it would continue the plan that was calculated in the reactor. But this would not always work, especially if you would happen to need some of the modules that were just pruned from the graph. And I'm going to try to illustrate this using a demo, so bear with me. And let's hope it all goes well. We go to Maven 3, and we have our implementation class here. Is this also readable for the people that are in the back? I see most thumbs going up, so let's continue this way. Now this is a calculator, and it has an add method, but I'm not really the quality developer that I pretend to be, so somehow I implement it using subtraction. Luckily, we have tests in place, and before we invoke those tests, let's verify we're on the right version of Maven. We're on Maven 3.9.9, which is great. I'm going to test my project. Yeah, let's do it this way. Maven test, that should typically work. And I expect this to fail. I'm not disappointed so far. But, well, of course I can fix the bug. That's an easy part. And now it says, after correcting the problems I just did, I changed subtraction back to addition. You can resume the build with the command maven-rf, which is short for resume from, module B. Who of you has tried actually doing that? Great, quite a few hands. How many of you were successful in this kind of scenario? Wow, not that many hands left. Quite a few, and well, we can discuss how that was possible, but for most people, this is not successful. And to me, personally, I find that very annoying. If the tool says you can fix it like this, and I do exactly what it tells me to do, and it still doesn't work, I get annoyed. I get mad. I start throwing bottles around. I won't do that this time. But just for the sake of the demo, let's see what happens. So I'm not used to this Windows machine.
Oh, sorry.
I'm resuming from module B. And, well, actually the error message is pretty helpful. Could not resolve dependencies for module B because there's a dependency on module A and I can't find it. All right, I know about this. I've had my Maven course in the past. And there's also make for that, which says if I have a dependency on something else that is also required, please also make that. Still doesn't work with the exact same error message. And this is typically where I start throwing bottles around. No worries for the people in the front row. I won't be doing that today. What happens here, as I said, first resume from is applied. So module A is all forgotten about. Then we build the project. There's a dependency back on module A, which is not in the reactor anymore. And Maven says, I'm sorry, it's not in my reactor. I can't resolve it in my repository also. So I have no other option than to fail the build. No, I shouldn't navigate to this other directory. I should just stay here and activate Maven 4 and redo the exercise. First, let's verify I'm on Maven 4.0.0 beta 4, which is the latest and greatest. Again, I'm going to introduce my silly bug. Again, I'm going to run Maven test. Should still fail, right? Still fails. Now there's another thing I want to highlight that changed, which is that Maven no longer says resume from module B, but it says resume, or -r for short, which is a way of Maven trying to help you. I know where the build failed, and you probably want to resume from that exact point on. So you don't have to tell me anymore. I've remembered. It's okay. So let's try if Maven this time lives up to the promise, and just say resume and activate the test lifecycle phase. Still doesn't work. A bit surprised, because this was supposed to work.
Did you fix the test?
I didn't fix my test, thank you. You're so helpful, all of you. As I said earlier, Maven is not going to fix the problems that you've created yourself, and I've just showed that, right? So, but this time my build was resumed from module B, but it was still able to activate, to refer back to module A. And that is, what we just saw is basically the first part of the demo, where even also make didn't work. This is where the myth was born that you always need to run Maven clean install. But the first and the second rule of the Maven Club is you shall not run Maven clean install. People ran Maven clean install because they figured, well, okay, I fixed the build. Hey, it can't resolve module B or module A or whatever it is. Oh yeah, let's just install it. And if I install it, it ends up in my local repository, my user repository, your home directory on Windows, Linux, or Mac, M2 folder, repository folder, which gets polluted with all builds of your projects that are no longer relevant. And here's a caveat. Resume from can work if you've installed your project before. The caveat is, though, that it may refer back to an older version of what you've been building. Maybe it's 1 day old and you're lucky. Maybe it's a week old and things get hairy. Maybe it's a year old and you're just probably building the wrong thing. Things get even worse if you use, for example, Maven package, because then you probably expect Maven to work with the jar that you've just packaged, but it's only in the target folder. It's not in your user repository folder. So what are you building against? Well, the thing in your repository, not the thing in your target folder. So Maven 4 will do a different approach. It will make this mental model, which we keep in memory. Then we start pruning the graph of what needs to be built. We apply resume from, projects, also make, all that kind of stuff. But when we start building, we take this original mental map of the project, so that if the build asks for module A, for example, we can actually resolve that from the project itself. And that is what you as a developer typically expect. And if we have this, then we can finally adhere to the third rule of Maven Club, which is that we just run Maven verify and not Maven clean install. I have to thank Andras Almira for this, by the way. He keeps a brilliant collection of Maven-related memes on his GitHub repository, and all of these memes came from there. There's a lot more which you can browse, and if you want to yell at your coworkers for not understanding Maven, there's probably a very suitable meme in that repository that you can just throw in their face. Then finally, we have a few more command line arguments that we have been introducing in Maven 4. The first one is the PS argument, or project settings for short, which allows you to specify a settings.xml that is not the settings XML that ships with Maven. It is also not the settings.xml that you keep in your user directory, but it is a settings.xml that you can keep in your Git repository next to your project. Which is nice because it means you can share it with your coworkers, for instance. It's also time to say goodbye to a few command line arguments. If you would ever have run Maven help with Maven 3, you would have noticed that there are 4 command line arguments which have a very interesting description: ineffective, only kept for backward compatibility. Well, I don't even know what they do. Apparently Maven itself doesn't even know what they do, except just sitting there. And well, if you are going from Maven 3 to Maven 4, you can make breaking changes, which also means you can drop stuff that you no longer need. If this is a description from the help message, ineffective, I think we can safely say that it's time to say goodbye. We have time for questions about what we've covered so far. Yes, please. What's the difference between -s or -s and PS? S refers to the settings. There's basically a hierarchy. So PS is project settings, and they go after the regular settings. So you can have settings on your user level, and then you can have settings on your project level that may override what was in your user settings. But maybe you as a user also have settings. Let's say, for instance, my repository does not live under ~m2/repository, but it lives somewhere else, where it doesn't get backed up or something like that, or it doesn't get virus scans, or well, could be all kinds of reasons.
Yes, and probably the passwords are in your home directory, in those settings XML, and not in the global Maven.
I hope you store them in your settings security.
Even better. Yes. Well, that's That's another topic maybe, but yes.
Yeah.
It's about masking the passwords. The
Yes.
passwords itself are there in the settings XML, but they're masked. Okay. More questions?
Any other questions? Yes, please. You'll probably have to shout, but we'll try our best. The question is, what does Maven remember when you use the -R feature? And I think the best way to illustrate that is to take a different terminal first of all. Because I don't know from heart, that's the honest answer, but I can tell you. So I'm going to make the build fail again. And now, if all went well, we can see resume properties here. And in the resume properties, what we see is right now there's only one thing it remembers, which is which projects do I still have to build? I had a plan of building this project, which included building module B, module C, module C1, module C2. I did not get the chance to do that, so this is what I still have to do. But you can also see it's a properties file. It has a key and a value. So it has been designed in a way that you could add more stuff to it. But that's not in there right now. Does that answer your question? Perfect. Any others? No. All right. Then, we're a little bit early, I think, to have a little break. But why not?
Yes, I think it makes sense because
Yeah,
you don't want to do it 5 minutes after my talk and say, okay, let's now have a break.
No. I don't even dare to. All right.
Why not?
Then, shall we continue according to our original plan, or shall we just say we have, let's say, 15 minutes break and give you a bit more time for the next part?
That's fine. Yes.
All right, let's go for a 15-minute break. You can refuel, get a cup of coffee or some other beverage of your choice. And then...
20 past.
Yeah. 2:20, we will continue. And you are free to keep on sitting or to walk around a little bit, whatever you prefer.
So who has tried in the break Maven 4 on his own project? Raise your hands. Here's one. Perfect. Did it break the build? No, of course not. Great. So who's ready for the real deep dive?
Oh, well, thanks.
No, so in the first part we talked about the extra arguments, the things that have been added or removed. But you could wonder, does that deserve really the step to Maven 4? Because we could have done that in Maven 3 as well. It's not that big, right?
With a little bit of extra effort, we would have been able to squeeze it back into Maven 3.10.
Sure, we could have done that.
Nah, let's not do that.
Let's not do that? No. So let's talk about the real thing, what makes Maven 4 different than Maven 2 and 3. Let's not talk about Maven 1. So let's talk about the project object model. This is short for POM. No, POM is short for project object model. Right. So with Maven 2 and above, so Maven 3 and also Maven 4, it's all based on a single point of definition, and that's the POM XML. It has all the instructions to build your project, to generate reports. Everything is there, almost everything is there to create your artifacts. But there's one issue with that, because this POM file is exactly the same as the one that's being installed or deployed to a local or remote repository, which means this file is used by a lot of tools, not only by Maven itself. So because it has to be exactly the same, we cannot simply change that. So here you see that the one you have on your local system is exactly one-on-one, exactly the same as you're deploying, and that blocks really innovation on that file, right?
Yeah, I can't count the number of times that people have been asking things like, why don't you just change this or that in the POM?
Right.
The syntax for a dependency is so verbose.
Yes. So let's give a couple of examples what's missing. And one of the things that's missing is encoding. So source encoding, resource encoding. This seems quite important. By default, it probably picks up the encoding of your operating system, which can be different between Windows or Mac or whatever. So it does not make your build reproducible. So it would be great if you just could explicitly say it in your POM file, use this encoding, so it will be exactly the same for all environments. Global dependency exclusion. Who was suffering from the log4j thing a couple of years ago? Wouldn't it be great if you somehow could define, okay, just remove all my log4j dependencies? That would be great, right? So the only option you right now have is to use the Maven Enforcer plugin to say, okay, ban this dependency, but it gives you a warning. Yes, so ideally you want to have it out of the box, just be able to remove it. And the Enforcer plugin, it is a great tool, but it's just protecting yourself. It's not really the solution, it's just protecting you from certain situations. The scope import of plugin management. So this has to do with BOM files. Who knows BOM files? That's not enough. We need to talk about it as well sometime.
Maybe we have time later this afternoon.
Maybe. So with BOM file, you can specify a bundle of dependencies that belong to each other. But with plugin import, you probably want to have exactly the same. Give me just a set of plugins that are just there, and I want to use them. Now you always have to specify them one by one, explicitly say the version you want to use. It should be easier than that. But currently that's not possible because Model 4.0.0 is Model 4.0.0. We cannot change that. Mix in POM fragments. I guess we have a lot of Spring Boot application developers, right? And what do they do in the beginning? They say use this parent, which is actually the Spring Boot parent. However, if you work in a company, you probably would like to use your company's parents. So there are two parents. That's not possible currently. So with mixins, it should be possible to say, okay, I have multiple parts of a POM file and I can combine them in my own build file. And that should reduce the maintenance of all those kinds of things. These are all kinds of dreams we have. The quality management section, there's no reference to, for instance, SonarQube with explicit details where to find it, etc. Code formatting section, it's always currently a file outside of it. Would be great if the POM file also supports something like that. Advanced control over plugin goal execution order. As you might know, you can only specify a plugin once in your POM file, but suppose you want to control the order combined with another plugin. We've had situations where we just could not solve this. Separate site distribution management. I'm not sure if people are really using the report sections to publish their documentation to a specific site. But with the normal artifacts, there's a separate snapshot and release repository. For a site, there's only a distribution management section. And it would be great if you could also separate that for snapshot and releases. XML attribute set support, also something that would be great to have. And there's much, much more. Currently, just not possible because we have this POM file, and it's all predefined what's allowed and what not. So sometimes we do have a workaround, and this is probably one you all should know or are aware of. Who recognizes it? Yes. So this is the workaround for an element that is missing in the POM file. So normally you would probably expect your project element, and inside the build element you could specify the source encoding. It's not there. So, but by using it as a property, it is still accessible by plugins. Just refer to this, and it will pick up UTF-8. So suppose that we will have a new POM file with this definition. Those plugins can still use exactly the same label to get this UTF-8 value. The next one, I think this one is tricky. It's about exclusion. This is, I think, introduced somewhere in Maven 2, where they said, okay, can we make it possible to just exclude all my dependencies? And I said, well, we can do that. We can say a wildcard. So in Maven terms, any group ID, any artifact ID, just exclude it. Now there was one project that had issues with it, or it was not picking up this soon enough, and that was AND. Because AND was using the original matching mechanism, and it was just matching the group ID. Oh, does this match the wildcard itself? Is the group ID really wildcard? No. Asterisk? It's not. Okay, let's include it. So it had exactly the opposite result. Yes, it was actually including everything instead of excluding everything. Again, this is a workaround. These things should be better, and that's also this makes it quite important to have these specifications clear. Now, who's reading all these POM files? It's just not only Maven itself. Of course, Maven itself is the main reader of the POM file. But we have artifact repository managers. We have other build tools. Maven is not the only build tool that is reading the POM file. We have CI servers that are interested in the POM file. We have dependency updaters like Dependabot and Renovate. We have editors and IDEs. We have further and other. And here we have our ABCDEF list of POM readers. Maybe we have like the whole alphabet. we had to.
If just we had more time.
If we had more time, we probably would have gone all the way to Z, right?
Yeah.
Okay. Yes. So these are all POM consumers, and that's why we have this term about the thing that will be in Maven 4, and that's the next slide, by the way, because this is about model version 4.0. It is just the metadata file for Maven Central, and it will not change. Yes, it will be there forever. So even though if we think of a new format, it has to be ported back to model 4.0 so everybody can consume it. And that's why we have this build consumer POM separation. So what we want to make clear with this is when to use what of the POM file and why. So at your own system, we have the build POM, and what it does, it is located in the source repository on your own code base, and it is actually the configuration file how to build your project. No surprises there, I hope. The consumer POM, that's actually the one that is being installed, deployed, uploaded, or whatever to an artifact repository. And it is accessible via a Maven coordinate. You all know the group ID artifact ID version. And based on that, you have the URL, and you can get your artifact. So this is used for referring to dependencies, Maven plugin, and extensions in your own build POM. I hope no surprises so far. It's just about we're trying to make clear which part is really useful for building a project, and once it has been built and deployed, what's still interesting, and that part is the consuming part. So there's actually a new flow now. So we have the build POM. This is indeed the POM file in your own code base. And what we're going to do with Maven 4 is we're going to enrich this a little bit. This internally, and after that we will have a consumer POM. And thank God it is generated. You don't have to do it manually. And this will make sure that it will be ported back to a model version 4.0 compatible file. Right? Good.
So far, so good.
So far, so good. So what we see in the current file, the POM file, is there quite a lot of redundancy. One of the things is like this, the model version. So if you take a look at the whole shebang of what is attributes and whatever, it is actually saying I want to use model 4.0. Wouldn't it be great to just remove it and to say, okay, I know I'm using this XSD file, so let's use that as the value for the model version. So this is something that we're going to do with Maven 4. So it will be possible to remove the model version 4.0 if you already specify the XSD version there.
And that's why we need a new major version of Maven.
And that's why we need a new version of Maven.
To remove one XML element.
Oh, I think we can do more.
Are you sure about this? Or?
Sure.
Okay.
Well, otherwise it will be a short deep dive, right?
Yeah. Then we would just be done by now.
Yes, well, I'm already a new coffee break now. So let's talk about the context of the POM file. So like I already said, you have the POM file on your local system and in your artifact repository. And there are actually two very important sections. One is the build section, and the other one are the dependencies. Of course, on your local system, both build and dependency parts are very important. You need to build it, and you need to know the dependencies. So once it is being uploaded to your artifact repository, either your local repository or your company repository, of course it is still interesting to have the dependencies inside that POM file, but why is there still build information? Who's using that? So this makes probably a little bit clear about there's really a difference about the information that is important on your local system and what's still important once it is in your artifact repository. Ideally, we could maybe even remove the whole build section, but we're not going to do that for Maven 4. Maybe Maven 5? Nah, probably not, because there are way too much users of the POM file. We just don't know what they are all reading of that POM file. As you might know, there are also a couple of relative system paths in your POM file. Who knows the relative path? Right, yes. So this is especially in a multi-module project with a couple of directories underneath each other, and with this you can point automatically. This is, by the way, the default, so it means that if you have a POM file in a directory, it will go one up and expects the parent to be there. If it's not there, but you know it's somewhere else, you can change this path. And there's another one, modules. In Maven 4, we're going to change this name because modules is now a little bit conflicting with the module system of Java.
But we were first.
We were first. Yes, we were first.
We're using the name module, just to point that out.
Yes, we were also first with transitive, and that's also a term they used in a module descriptor. So, and it's not exactly the same. It's not the same at all. But here, this is when you want. This is for aggregators. If you want to build multiple modules at the same time, I'm saying modules. Then this is the way to do that. You can refer to another directory. It doesn't have to be in the same directory. You can also go deeper or next to other. Just mention the path to another module and you can build it. So if we take about this parent and redundancy, once the POM file is uploaded to an artifact repository, of course, it has to know the group ID, artifact ID, and the version. But the relative path is not useful anymore. It's actually useless because you won't find the parent in that location. Absolutely not. The relative path on your local system is very useful because based on that, it can detect the group ID, artifact ID, and the version. That's all resolvable via the relative path. However, it's back to one of the first slides we had. The file on your local system is exactly the same that is being uploaded. So if it is required for one of the two systems, it has to be there explicitly. And the result of this is, well, let's have a look at it. I think it's this one. Yes, so here you see all the files have just exactly the same version. Well, ideally, you just want to have one version updated. And at the bottom, there's also the project build output timestamp that's required for reproducible builds. So actually, I would hope to have a commit with only 2 changed values, ideally. Maarten still agrees with me?
3.
3?
There's also a tag.
Oh, yes. Okay.
Yeah. But I'm still with you. All these other files shouldn't need to be changed.
It should be just one file in the root of your...
This is when I build it, this is what I built, and this is the tag in version control. Right. Be done.
Exactly. Okay. Dependencies. Again, once it is in the artifact repository, of course you have to specify the group ID, artifact, and the artifact ID and version. On your local system, of course, if they are part of the multi-module project, you need to know which dependencies you use. But you could probably resolve the version based on your whole reactor, as Maarten already explained in the beginning, because you have this graph. You have all the information. You know, okay, in this graph, I know that this group ID and artifact ID has this version. So why do I have to copy that if I build the whole multi-module project? So these are all kinds of things we could already improve if there was a way to have a separate build POM and a consumer POM. Now this is also a very interesting thing, the CI-friendly version. Who is familiar with this? Karl-Heinz, what a surprise.
Free. I see another deep dive upcoming.
Yes.
There's three people raising their hands.
Okay.
And there's a little bit more than 3 people in the room.
Okay.
So
do you know the reason why they introduced this? Oh, this was not your slide, right? This is my slide.
No, I don't.
You don't? Okay.
But I'm not alone. There's a lot of people that don't.
Yes, right. Let me help you a little bit. This makes it possible to have every commit be a releasable object, artifact, right?
Potentially
Potential releasable.
Cool.
Yes. And normally, what we're used to do these kinds of things is to use the Maven release plugin, but it comes with some overhead. So wouldn't it be nice if you have some kind of extra parameter that gives you a unique value for this for the version? So there are 3 placeholders for there: the revision, the SHA-1, and the change list, and you can add that to your version. So it would.
So change list. If I read the name, I think of these long change logs.
Yes.
As a version number.
Don't ask me those kinds of
Okay.
details. Just know there is a placeholder there you can use. You can fill it.
I mean, these first 2 do make sense, but
right.
Yeah.
Okay. So forget about it. Don't use that one.
Okay.
Go for the first 2.
Yeah. First 2.
Yes.
Got that.
Okay. So this was actually, I call it a half-implemented feature. It works fine for just standalone projects, but in case of a multi-module project, you are probably a little bit kind of doomed. So suppose I have a project and that depends on lib 1.0. Yes, and this one makes use of this SHA-1 placeholder. So it has been uploaded and it has the lib 1.0 cafe.Did. So I can just download it. It's a URL, I can download it. And at that moment, Maven is not really interested anymore in the artifact group ID, artifact ID, and version inside the project, because it already has downloaded. It is not double checking if those values match. However, if there's dependencies, in this case it says, oh, the version is project.version. Let's have a look at the value of project.version. It's 1.0 SHA-1. What's the value of SHA-1? I don't know anymore. Yes, it was uploaded with cafe.Did, but that information has lost. So that is really the issue, and it would be great if Maven would have solved this by default. However, again, in Maven 3 and also with Maven 2, the file that you were using at build is exactly the same that's being uploaded, installed or deployed. So there was a fix for this, a kind of a workaround, and it required a Maven plugin, and it was actually a third party, so it was not maintained by the Apache Maven committers or developers, and that was able to rewrite your POM file. So it was able to, you just had to add this extra plugin. I'm not going to call it because you should all move to Maven 4. But the idea is that just before installing or deploying, it will replace these kind of values in your POM file. Attach that to your in-memory object, something like that, and use that to be installed or deployed. So this makes the flow of the POM file a little bit different. So we have the POM file. It's still the one that's in your code base, and then we have the enhanced POM file. And now we know what we can do with it. We can add versions, like the model version. We can add the version to the parent. The CI-friendly version can be solved, and also the dependencies inside Reactor. If we know their versions, we can also update those for all the dependencies, so that other projects can use them. And then we have the consumer POM, and we can actually clean up a little bit of things, because we're not really interested in a relative path anymore. We can remove the modules, because they expose a little bit more about your whole build structure. So it's just a little bit of cleaning up. We could probably do much more, but let's do just these things that just totally don't make sense and nobody's interested in. If you want to use Maven 4 but don't like this whole build consumer part, you can
why wouldn't you?
Ask the audience.
Why wouldn't you?
Why wouldn't you? Like, nobody wants. Okay, so
Okay.
let's go to the next slide.
Next slide.
Okay. So will the consumer POM only contain dependencies? Like, I hope you heard my story and noticed that no, currently we're just resolving some missing values, and we're cleaning up things that are related to your local system. However, I think this separation is that important, and it can have a lot of impact, that maybe after this we can introduce a new file that is probably better and only contains the dependencies. It will be much more efficient, because right now, if you want to know all the dependencies really of a specific artifact, you need to know the logic of Maven, and I don't like that. What I would like to see is to have a POM file and just have explicitly, okay, this is the list of all the artifacts you need to use to have this library. So that means that your dependency tree will not be like 20 levels deep, but only 2, ideally. So you only have your own project, your direct dependencies, and their dependencies, and that's it. So that should also probably make it a lot easier to solve those kind of weird conflicts that you can have right now. Yes.
Don't even get me started.
No?
No.
Okay. So finally, we will have a model 4.1.0. And maybe we should first have a comparison about how a Maven 3 and a Maven 4 project would look like.
Yeah.
Yes?
I guess that makes sense. By
Yeah.
now.
Right. So here we have a Maven 4. And I have a diff as well. I thought I have the diff. Compare. Not yet anymore. What?
I think you had it open. Isn't it that one, for instance?
Well, yes. So here you can see the things I all removed. So you see the model version has been removed. From the parent, I could remove also the version because they are being resolved. Here, from the dependencies, I can also remove for module A the version, because it's already part of the reactor, so I can build that. And if I go to the Maven 4 example, so this is the one. Let's try to build this first with Maven 3. Maven verify.
You need to go into the directory. Project.
Yes, this one. It will complain about a lot of things that is missing. And in terms of Maven 3, this totally makes sense, because parent version is required, model version is required. Let's go for Maven 4. It all works as expected. And with this, your release will only be like 2-3 things that will be changed in a single file. So this will also probably make it a lot easier to maintain your own project.
Maybe you should show the consumer POM to prove that it
Oh,
actually generated
yes.
something that is backward compatible.
Right. That's a good thing. So it's telling me probably as well that it's generating the consumer POM, right? Yes, so here it says
POM consumer, one line below.
This one. No? This is the consumer POM, right?
Yeah.
Right. So if
I
we
guess you want to show that consumer POM to prove that it is still model version 4 compatible.
Right. So let's go here, and we have the target directory at the highest level, I guess. Target. I'm a little bit confused. This one should have the local project, right?
it's there.
Oh, I'm already in there. Oh,
Yeah.
great.
VS Code is such a great editor.
Yes. Okay.
And this is how you know we don't work for JetBrains.
So this is the original POM file. You see we're missing the version in the parent, and in the consumer POM you will see that this has been added. And there's one more interesting, I think.
This one doesn't have dependencies, so
no, this one.
the difference is less clear.
Okay, which one has B?
I think B or C2 does.
B. So this is the one which has a dependency on module A. It doesn't have this looks a little bit like if you're using dependency management, right?
Yeah.
So, but interesting enough here, you will see that one snapshot has been added.
Now, what if I have a dependency on another module in my project, but I don't want the same version as I'm currently building? Would that still be possible to overwrite that version that gets resolved from the reactor?
Let's give it a try. Why not? Okay, so you're saying that, for instance, we're giving module B a different version.
Or you could depend on version 2 of... Well,
like this?
Yep.
Okay.
Let's see.
Is one of them depending on module B?
C2 does.
C2 does. Okay, great. So let's try it again. Are we going to do a clean? No.
Living on the edge. Did you actually save the file?
Did I save the file? Ooh, great question. Now I did. You're expecting it to fail?
Kinda.
Nope.
No. Why not?
Why not? Okay, so what we did here is we see that module B has version 99, and because the consumer is now aware of its old context, it will be able to replace any reference to module B and add version 99 to it.
So you're saying in the consumer POM of module C2, we should see version 99?
That's what we should see.
For the module B dependency.
Yes, that's what I would expect.
In the build, in the target folder.
Targets. This
Then
one,
module
C2.
Then the consumer.
Consumer.
99.
99.
That's great. Works as expected.
Yes, finally.
Finally, yeah.
I think I started working on this in 2017, I think.
Ish.
Yeah. Oh, Karl-Heinz, not so. Yes, probably. That was still based on XML templates because it's XML and it's a transformation. Yeah. So for me, it made sense to do that. So now it's completely rewritten to something else.
At least once, maybe even twice.
Probably, but we had to start at a certain moment, right? And just to make sure that it works. So based on what I wrote at that time, I could also already say, okay, I expect this as the output if I leave out these kind of values. And even after rewriting, they're tests, so they can be verified all the time. So even after refactoring all those code, it's very valuable to have those integration tests. Okay. Let's go back to the slides. So we have this model version because we already noticed that we can go from model 4 to model 4.0.0 by just adding and removing a little bit of elements. But if we can already remove or adjust the POM file, maybe we can do more. So one of the things that has been added is, for those who are familiar with XPath, probably not a lot of people. Oh, there. Great. Oh, more.
Quite a few people. That's great.
Still XML friends. Great.
That to YAML.
So the project has a new attribute, and it's called root, and it has the value true or false, and with that you can explicitly say, okay, within my multi-module project, this is the root of the whole project. Why is that important?
Well, for one reason it is important is to actually help Maven determine where your multi-module project ends. Remember that I said that Maven has this mental map of all the project dependencies and the hierarchies. There's kind of a fallback mechanism that just keeps on navigating up and up and up and up and up, and eventually you would end in C colon or slash if you are on a non-Windows operating system. So this is kind of a helper for Maven to say, okay, it makes no sense to navigate even further up and hope to find a parent module.
Right.
That is at least one of the reasons I'm aware of. There may be more that I don't know.
The project awareness, we're talking about it later, right? Or
Not sure.
Not sure?
Not sure.
Okay.
We'll see. Let's keep some surprises,
okay.
right?
Okay, that's good. Okay, this one I think already mentioned it. This is about a conflict about the word module. So we will now have sub-project and sub-project. It's just a replacement. You will get a warning about it if you're still using modules. Modules will still work. This is just a way to get rid of the confusion. Execution priority. We talked about this this weekend, and we were like, this is weird. So what I did is I just compared the two XSD files, and I noticed this one without really looking into the details how it is being used. But it's there. But maybe it can already be removed because there's a different solution for it. And Maarten will show you that after the coffee break.
Don't spoil it.
It's not a spoiler. It's,
No.
it's trying to get people back after the coffee.
Okay, yeah.
Yes?
That's a great thing.
Okay, good.
Yeah.
So, and the other one is extensions. So who is familiar with plugin extensions? Yes. Those are the numbers I always see. So, it's always hard.
It's an acquired taste. Let's say it that way.
Okay, so what I normally say is with plugins you really have these steps from plugin one to the other. But sometimes you have things that are they're important for the whole project. For instance, I think I did a talk at JFall with Raid Sang, and we installed some kind of notifier extension. And the notifier extension, what it does, it can give you a sound if the build fails. Yeah, so this is typically a thing you don't want to specify as a plugin, because then you have to define it everywhere all the time. And how do you know when the build fails? So this is something that's inside the ecosystem of Maven itself. You want to adjust a couple of things how Maven itself is working.
I think you also made a more serious extension. One that blames you when you run Maven clean install when you shouldn't.
Oh, yes. Indeed. Oh, I totally forgot about it.
I mean, who cares about colors or sounds?
Yeah, so this one was indeed counting the numbers of Maven clean install when you did it. And if you
but you shouldn't have done it.
And you shouldn't have done it, yes. Yeah. And when you did it 3 times, it would just fail the build. Again, this is not...
You're being stubborn.
It had a great name. Do you still remember it? No. I think it was CI. Well, I think it was the CI extension because it seems like it refers to continuous integration, but it's about clean install.
Oh, that's awesome.
Yes. Okay. Enough about that. And the last thing is the profile activation package. So this is about. Sometimes you want to have something executed when it is a jar file, and you want to do it globally. Currently, that's with Maven 3, it's not really possible. With Maven 4.1.0 model, it is possible. So what you can say, okay, I am of packaging jar. In that case, also run code coverage, because it does make sense to run code coverage over just POM files or static content or whatever. So that makes the flow even a little bit more, well, I'm not sure if it's more complex, but more complete. And so we still have the POM file in our code base, we still add versions, and then in the end, we don't only remove the local system entries, but we can also remove and transform the new features back to a Maven 4.0 compatible version, so it can be consumed by any other tool. Clear? Yeah, it's clear for you. And
Gradle, SBT,
all of them. Yes.
ABCDEF.
ABCDF. All
Great.
those tools can use that because it's transformed back to a Model 4.0. So right now, I have time for coffee, but not before I can answer some questions. But I'm pretty sure, because this is really complex. It took a lot of years to get to this point, but at least now we have the alpha and beta releases. You can all use it. But are there any questions? If there are no other questions, I would almost say go download and try it. Otherwise, let's have, again, a small break of 15 minutes. Yep. And get back at 3:15.
3:15, it is.
Okay, thank you. We're just discussing about the number of people that are still sitting here. We're impressed.
Pleasantly surprised.
No, not surprised. I'm not.
Okay, you're not.
No, it's a compliment for the audience, right? Okay. I hope you all had your coffee. I didn't, actually. So.
We should have grabbed the coffee, too.
Yes.
Never mind. We'll do that afterwards.
Right, good. Okay. The last couple of slides. And let's start about the changes that are important for library developers. Because I expect most of you are application developers, and we started a couple of weeks ago with also a slide just for application developers. But we noticed that for them, the changes, they don't have to change their way of work a lot. They don't have to know about it.
We had the TLDR for that.
Exactly.
Yeah. Who here is actually considers themselves a library maintainer? I mean, otherwise we can just skip. Oh, okay. We shouldn't skip it.
Okay, we're not going to skip it. Okay, good. So one thing that we're going to introduce is the BOM packaging. So you're all familiar with the jar packaging, POM packaging.
EGB.
EGB and WOR or WAR files. Yes. Okay, but we're going to introduce the BOM packaging file. And what it does is you define it just as you're used to, but you can omit the versions because we know that with Maven 4 they can be added automatically. So we have a demo for that. This one. Maybe I should show you how it looks. So here we have the BOM file. I hope everybody can see it. And what I've done is, in the dependency management, I summed up all the dependencies that are part of this multi-module project. And maybe that's also one good thing to note, to mention, is what is actually a BOM file. And a BOM file contains all the dependencies that must be in sync with each other. So in case you're building some kind of Spring Boot applications, you really want to make sure that all the Spring Boot acts with the Spring Boot group ID all have exactly the same version. And that's very important. So don't add just command lang or whatever to the BOM file, because it will confuse Maven and therefore probably confuse you, because it's going to do weird things that you're probably not aware of.
Now, I think Spring Boot is the classical example.
Oh, of course.
There are many more libraries nowadays that actually ship a bill of materials. I think Log4j does it, JUnit Jupyter does it, Quarkus does it, Camel does it.
Yes.
And for good reason, because it makes your life easier. Also
that, and because the maintainer knows which modules should be with each other in sync. Yeah. It totally makes sense, because if you do it by hand in your own POM file and you forget one, for some reason it could pick up the wrong version. I've seen it a couple of times. So
ask us how we know.
That's how we know, and that's why we thought, well, it's important to have this kind of thing. So let's do it like this. And Maven verify. Actually building much more than I think, because BOM file is one of the first thing it is creating. And if we now have a look here in the target directory, here, BOM file, you will see that the consumer now has all the versions here. So this one is ready to be consumed as a BOM file by all other projects.
It does have the sub-projects though.
Oh, interesting. Why?
I would say that's build time information.
How about this one? Interesting.
Yeah.
Okay, let's go. Always the live demos, right?
Let's just pretend we all didn't see this, right?
Yes.
There were no sub-projects in the BOM.
I'm indeed surprised. They should.
Yeah, it should be there, right?
No.
No.
Okay. Anyway, what you did notice is that the versions were injected with
Yes.
the right values.
Yeah, so if I'm going to consume this BOM, I'm sure I can be confident that I get the right versions of all these libraries that are declared inside
Exactly.
the bill of materials.
Right. So as I explained, this is what you should have in your BOM file. So here I'm saying explicitly public modules. The reason is that, for instance, Maven, especially Maven 4, has a huge number of libraries, but only a few of them should be public, because the rest is just bundled and you should not depend on them. However, if you're building a Spring Boot application, all those modules are public. And it rewrites the dependency management. For more details, you can go to this Jira. Don't do it now. I'm not sure how you can do that, but anyway, for Maven plugin developers, are we having those kind of people here? 1, 2, 3, 4. Oh,
5,
6, 7. Almost 10. I think we will touch 10. Good. So one of the most important thing is the model of the project model is now becoming immutable. So the plugin developers probably know that it is possible to add a couple of things to the model, and that will be transferred to the next plugin and so on, so they can make use of it. So for instance, adding source folders or something like that, yes. Now it's becoming immutable, so how do we solve that? Look into the documentation, I would say.
Yeah.
Probably most of those things are already solved there. So, but this is one thing you should just be aware of, that if you are trying to adjust something on this immutable model, you will can have surprising things if you depend on the mutability of that project. And Maven itself finally comes with the bill of materials itself. It's kind of funny, because we are already saying for like years that you should use it, but Maven itself never had this bill of materials. So now we have it. And like I said, it only contains the public libraries. So Maven core should be, I don't think it will be possible to, well, possible. It will be possible. It's not part of the bill of materials.
You can depend on it,
Sure.
but it's not going to be managed through the bill of materials.
Exactly.
So you need to specify the version yourself.
Which makes sense.
Just like last year.
Right. So these are actually the real changes for Maven plugin developers. And then we have a lot of other stuff, and that's your task, right?
Yeah, I think so. If it comes to unrelated gibberish spreading around, I'll do that. Sure, no problem. Now, there's a lot of other things, big or small, that we wanted to highlight, but they didn't really fall into another category, so we decided to just call it other stuff. So you know what you can expect. The first thing that we did is we did a bit of proper application lifecycle management on Apache Maven itself. So we went through all the dependencies that we have, both on Maven core and on the plugins, and well, let's be honest, if the only reason for including commands long is that you use string utils.is empty, then maybe, just maybe, you can consider copying that function. It's under the same software license, and get rid of a whole dependency, which saves your users a bit of download. And we had a couple of more of these kind of scenarios where in reality we were using this tiny service of a rather large library, and we decided, well, copying is better than depending on this only to use it for this one function invocation. The dependencies that passed this test and were allowed to stay part of Maven, most of them were upgraded, and we introduced a few new dependencies that we didn't have before for particular features. And Robert already suggested this when you discussed the bill of materials. We did a more fine-grained modularity inside Maven. So we made a clearer distinction of what is a public API that you as a plugin developer can actually depend on, and what is, well, let's say, an implementation detail that probably is not relevant to you. And I would say, when in doubt, look if it is declared in the bill of materials. If it is there, then you can probably rely on it, compile against it. If it is not there, this is probably a sign to reconsider, should I rely on this? It might actually be an implementation detail that I should not rely on. Now, you may think, oh yeah, clean up and upgrades, that's all great. Show me the details. Well, I did a little bit of forensics. With Maven 3.9.9, we had 35 external dependencies. So those are dependencies not inside org.apache.maven group ID, with a total age of roughly 67 years. I don't think we have many people here in the room that are older than that. I still need to wait quite a while for that. The average age, though, was 1.9 years, or almost 2 years, let's say. And with Maven 4.0.0 Beta 4, as I said before, this is the latest version as of now, the dependency count actually goes up, which may sound odd, but what we see is that the total age and also the average age goes down. Still, it's not impressive numbers. I mean, it's only 4 years of total dependency age, or, well, maybe half a year if we are really generous to ourselves, of average dependency age. And that is because we have a few outliers on both ends of the spectrum. We have a dependency on, I'm not sure if it's Java inject or Jakarta inject, but that's a really old dependency that's been there for ages. But we also have dependencies on Maven Resolver, which is a relatively new kid on the block inside the Maven project, but it lives in a different group ID, so we counted it in. But it is relatively young, and it gets recent updates even in Maven 3.9.9. So that's for application lifecycle management. Another thing that we added is new lifecycle phases. You may be aware with lifecycle phases such as compile, test, package, verify. And what we did is we added pre and post phases to each of them. So this means that it will become easier for you as a Maven user to say, oh, I want to do this straight after compilation, or right before testing, let me first do this or that. Some of these phases already existed. You may have seen pre-integration test and post-integration test, but I think that's also the only occurrence that we have. And now we have it for almost all phases. If you want, you can even change the ordering inside such a new lifecycle phase using the square brackets. So you can say square bracket 100, 200 to order 2 plugin executions that are bound to the same after column compile lifecycle phase. Let me quickly show you an example of that. I think it is here, but I'm not sure. Extra phases, there it is, yes. So what we can do here, if we have the extra faces profile, I'm going to show you in a minute that it actually works as we expect. We can say right after compilation, after colon compile, I want to run the resources goal of the resources plugin again. I'm not saying this is a good idea. I'm not even suggesting it makes sense because it doesn't. But it's just to show you that it works. Double check we're on 4. We're on 4. That's great. Yeah, let's go for test. Oh, and obviously I forgot to actually activate the profile, so nothing notably changed. Colon P for activate profile. And we see that we have the compiler plugin, and then we have the resources goal of the resources plugin after compile, and it is just processing the resources again. I also mentioned we have the square bracket notation. Usually what you would expect is that executions are run in the order that they are defined, so 200 and then 100, but because of the square bracket notation, we can actually alter the order in which these plugin goals are executed. And I'll activate that profile as well. And now we see after compile 100 and after compile 200 in the reverse order than I declared them. So we can really have fine-grained control over the order in which all the goals get executed. Another thing that we changed is that there is now a project local repository. You may already be aware and familiar with your user repository, which lives in your home directory, the m2/repository folder, which acts as a cache for the dependencies that you downloaded from the internet. But it could easily get polluted, especially when people were doing Maven install. But you aren't doing that anymore, right? We covered that. No more clean installs here. Still, if you build a multi-module project, you do produce a jar file, and another module inside the same build can depend on that jar file. Well, it gets resolved from this project local repository so that you can see which file gets used, and there's no confusion between, but I did compile, but I did not package. Now, what is it going to use? Or I did package and then I did compile. Which of the two is newer? What will it use? There's no question of that. Just to be absolutely sure about this project local repository is not yet another many gigabyte folder on your hard drive. I mean, I know some people have been wiping their M2 repository folder because it became tens of gigabytes large, and I fully understand that. As I said, it is kind of a cache to what you download from the internet. This project local repository only contains the artifacts that you produce in that project, in that build. Resolving still goes to the user repository, which lives in your M2 folder. Because we decided that Maven 3, the next version would not be Maven 3.10 but 4, we finally had an occasion to remove things that don't work or should not work. And I already mentioned those 4 little friends that say not effective, kept for backward compatibility. Well, here's another example for you. In Maven 3, it was already there was already a change from Maven 2 and probably even Maven 1 to no longer have POM expressions as the primary way to resolve properties. So what you can do inside your pom.xml, you can use this special $curly brace syntax and refer to other values inside the POM. A very popular use is, of course, the properties section that lives in your POM, but you can also use it for, well, let's say, the target folder of your build or something like that. You could have done that through pom.build.target directory, but in Maven 3 this was already deprecated. It should have been project.build.target directory. Well, we already mentioned Maven 3 is now 10 years old. This means you had more than 10 years to remove it. Oh, well, this giggling is worrying me in a bit. We're going to help you a little bit. In Maven 4, it just no longer works. And if I say it no longer works, this means that if you still have it, then Maven will interpret it the way it is. $curly brace POM dot whatever curly brace close. If you happen to have a file with that name, congratulations. If you happen to not have such a file, bad luck. But really, 10 years, it should be enough, right? I don't even think we warn about this anymore because it has been 10 years of being deprecated.
Yes, probably.
I think so, yes.
You think
yes.
so? Yeah. Another one, and this may be a bit controversial, is that Maven 4 will require Java 17 to run. And if you think this is controversial, fine, we can have a discussion about that. There was a large discussion on the mailing list. Those who are active in the Apache Software Foundation know that the golden rule is if it happens on the list, then it's the truth, and if it does not happen on the list, it did not happen. Well, this definitely happened on the list. It was a huge mail thread about should we upgrade our Java version. Just as a reminder, Maven 2 required Java 1.4. I've been working with Java 1.4 in the past. Then 2.2 required Java 5, which was the same for Maven 3. Maven 3.9.9 that we use nowadays is requiring Java 8 and Maven 4. And no, I'm not going to be tempted to add a year there, will require Java 17. You may ask why? Because
why?
Okay, yeah, I'm glad you asked. There's two main reasons I think that boil up from that discussion. The first one is Maven developers really looking to use new features in the Java language to write more elegant code, to write more compact code, to make older constructs that feel like, but I'm not doing this in my day job. Why am I still doing it here? Well, we can use a more modern language here. And as a nice benefit to you as a user, it means that you can, that we actually push you a little bit towards using a more recent, hence more secure runtime. Now, I'm actually waiting for people to shout something like this. No one? Oh, okay. That's a question that I got a few times when I mentioned this earlier. Does that mean, passive-aggressive voice, that I have to migrate my project to Java 17 because you are going to use this new language feature? And the answer is no. If you still want to use Maven 7 or Maven 8, be our guest. In fact, the demo project that we've been using the past, 2 hours, was a Java 7 project. Did anybody notice it was? Nobody did, right? I see no hands. Nobody noticed. The trick here, and it's not really that much of a magic, by the way, is that you need to have a careful look what version of Maven am I using to run Maven? Sorry, what version of Java do I use to run Maven versus what is the version of Java that my project requires? And those two do not have to be the same. If you run, let's say, Java 17, you can see your project. It requires Java 8. That's great. I'm going to define maven.compiler.source, maven.compiler.target properties, give them the value 1.8. Java 17 still supports outputting Java 8 bytecode. I'm good to go. Now, I can, of course, be in the unlucky situation that I have to work with an even older version of Java, let's say Java 7. We'll look into that in a minute, because for Java 11 and up, I forgot to mention that, but luckily I have my slides to remind me. It's not Maven compiler source, Maven compiler target, but it's just one property which is called Maven compiler release. So for Java 11 and up, you use that. Now, if your runtime does not support the version of Java that you need for your project, you can use toolchains. And toolchains is a way to further isolate the Java runtime that Maven uses for, well, basically running the plugin execution framework, right? Versus the version of Java used for compilation and running tests and whatnot. I think this calls for another example, another demo. There we are, yes. Let's ensure we are on Java 17. And let's run our tests. I'm going to run only up until module B, because that's the only module that actually does have tests. So just to highlight, I'm using Maven 4 here. Wait, I'm using Maven 4 with Java version 17, no cheating. And I'm seeing that the compiler plugin says, that's great, I will compile your source file with Javac, and I'm targeting Java 1.7 here. Perfect. Now I'm going to do the same thing, but with Java 21, or shall I take 23?
It's not on my machine.
It's not on your... What? You were supposed to install that. Java 21.
Yeah, 21.
It is. And I'm going to do the exact same thing. So I'm going to run Maven, run the tests of the module B. And here again, I'm seeing that Java 21 is selected. But my code still needs to compile against Java 7. And the first thing I want to highlight is this. Toolchain in Maven compiler plugin is a JDK that lives in CTools OpenJDK 11. Why 11? We'll see that in a minute, but JDK 11 supports compiling against compiling to Java 7 bytecode. Now, this does not only apply to the compiler plugin. The good part is that the test plugin, Surefire, also recognizes this toolchain. So it's not only me compiling Java 7 bytecode and then using a Java 21 runtime to actually run the bytecode. I'm not even sure if that's going to work, but even if it does work, there's probably a reason why I want to compile against Java 7. Maybe I'm using, okay, let's not call names, a very old-fashioned application server that still requires Java 7 to run. Running my unit tests in Java 21, even if that's going to work, gives me a false sense of confidence. It does not say anything about what will happen in production, because there I will be running Java 7. So that's why also Surefire recognizes the toolchain declaration. And the way we do that is that here in the pom.xml, of course, as it is our single point of definition, we activate the Java 7 profile based on the JDK version that is used to run Maven. So what this says is, with Java 20 and up, no upper bound, activate the Java 7 profile. What is inside the profile? Well, there's an additional plugin definition here. It's the Toolchain plugin, and we ask the toolchain plugin to select a toolchain that provides version 7 of Java until 20, but not including 20, because otherwise, on Java 20, we would get Java 20, but in Java 20, we actually looked it up over the weekend, support for Java 7 was dropped. So we cannot have anything that is 20 or higher, but anything just below 20 is fine. That's what the bracket says, and the square bracket says include Java 7. So this snippet activates the toolchain and tries to select a toolchain that matches my requirements. Now, then the only thing that we still need to know is, how does Maven know about these toolchains? Well, in my M2 folder, there is a toolchains XML file. Let's open. Yes, fully trusted. And here it says, if anybody asks for a toolchain that provides Java 11, give them the toolchain in this particular folder. If anybody asks for Java 17, give them that, etc., etc. And then the toolchain plugin is smart enough to say, okay, you asked for something 7 or higher, but not 20 or higher. Well, 11 matches that, so I will select this toolchain for the compiler plugin, for the Surefire plugin, for the failsafe plugin, and probably for a bunch of other plugins that I forgot to mention here. So in this way, your Java runtime for Maven is completely isolated from the one that you use for your build. And that means that Maven developers can be happy using Java 17, while you can still build your Java 7 project and be equally happy. I'm not sure about that, but you can still be happy with that. Then we have a few cosmetic things, and you might already have noticed it, or maybe you did not. Maven 3 was, in a way, a bit partying like it's 1980, also effectively limiting the output to 80 characters per line. I don't know about you, but my screen at home is a little bit bigger. Even my laptop is a little bit bigger than that. The only reason that the difference on this machine is less visible is that we increased the font size here a little bit, but you should still be able to see it. Oh, should of course not do this on a project that requires Maven 4. Maven validate on, yeah. So let's keep in mind it cuts off at roughly there. Can you just stand there and... No, just, just kidding.
No problem.
Okay, that's the cutoff point, right?
Make a picture.
And now we are going to do the same thing, and then the output, yes, it's wider. That's great. Yeah, this is really an interesting solution to. Well, never mind.
I felt very, very useful.
Yes,
Yeah,
well, not only on this occasion, by the way. It's not a really big thing. Let's be honest about this, but it feels odd if you live in 2024 and you see a terminal and it's like, oh, I'm looking at an 80s movie because the output is so cropped.
Let's even make it smaller. Control Min.
Is that Control Dash? Oh, it is.
Mm-hmm. Let's do it again.
Yeah, see, then the difference becomes a bit clearer. So that's basically all there is to it. Again, it's probably not something that you would have invested millions of euros in, although we totally appreciate if you do. But it's just there to make your life a little bit more, oh yeah, this is modern software and I can still use this. Another thing, and this may affect basically everybody, so this is for plugin developers, Maven developers, application developers, testers, everybody that uses Maven basically, is that we did an upgrade of the default plugins that ship with Maven. You may think, hey, but you didn't bundle plugins. That's correct. We don't bundle plugins ever since Maven We were not supposed to mention that name anymore. Yeah, never mind. So in Maven, there is a concept of a super POM, which you could say is the Java lang object of any project. If you do not specify a parent project, then you still inherit some stuff from a parent project, which is the super POM. And that super POM also includes version numbers for some Maven plugins that are really widely used. The compiler plugin, the Surefire plugin, the resources plugin, you name them all. And with every version of Maven, these version numbers are subject to change. And that brings a little bit of a challenge, because now, all of a sudden, it can make a difference whether you use Maven 3.9.8 or 3.9.9. The only way to be absolutely sure that you use the exact same build configuration up to the version of the Maven plugin being used is to do a diff of Maven 3.9.8 and 3.9.9 and see if that super POM has changed. Or, and that's probably easier, just specify the version numbers of these plugins in your build. And this may be a bit odd. I mean, many people are just used to, but the Maven compiler plugin is always there, and so is the Surefire plugin. And you're right, it is there. This is just you specifying exactly what you want to have, and not being subject to, well, let's hope it is stable. So this also greatly helps in creating reproducible builds, which is worth another deep dive, I think. The idea there is, to summarize it in one sentence, that it doesn't really matter who makes a build of a particular set of source files, the outcome is guaranteed to be the same. If you do not specify these version numbers, or in other words, if you keep on relying on what the super POM defines, well, we follow the same paradigm as we said before. We will warn you about this, because this is probably not what you want. It is not an error in Maven 4. I make absolutely no guarantees about Maven 5.
So this is, I think, also one of the discussions we had about, for instance, the Maven compiler plugin. I think with Maven 3, it was locked on 3.1.0. And we kept it for that for a long, long time, because if we there was this discussion, should we change the default value for source and target? That could impact your project if you rely on that default value. Yeah. So that you will get the works on my machine, because I'm building with Maven High, but my colleague is building with Maven Low.
Yeah.
Yes.
Yeah, that's the story of my life.
Story of life.
Maven Low. Well, another example where this kicked in, by the way, the Surefire plugin is now on 3.5.1. It got released, I think, the other day. But you may remember that the Surefire plugin had many, many milestone releases. They had 3.0.0 milestone 1, 2, 3, 4. I think they went up to 11 or something.
Hi
again. Again. Yeah. If you were not aware of this, you would, and you did not declare the version of the Surefire plugin in your build, you would, until recently, still be using 2.5.2, if I recall correctly, which did not even support JUnit Jupyter. Oh, you want to use JUnit Jupyter? Well, you first need to upgrade your Surefire plugin. That doesn't really come in developer friendly, does it? So, to summarize, we're going to warn you if you use any plugin that is not explicitly versioned inside your project object model. Will still work, but no guarantees for how long. And that really brings us to what we consider the end of what we have to tell you. And that is a call to action on your end. Go forth and test. As I mentioned a couple of times, the latest release we have right now is Maven 4.0.0 Beta 4, which is, I think, a month old roughly. Please go download it. Try it on your project. It can be a small project, it can be a large project, It doesn't really matter. It's your project. And you probably have somewhere in your project something that we did not yet foresee. And we want to find these kind of things. If you find something that does not work, and it does work in Maven 3, and I did not say, or Robert did not say, it's going to break, then you probably found a bug. Please be so kind. Bring it to the smallest example that still illustrates this works in Maven 3, no longer works in Maven 4. And report that using the issue tracker that we use for Maven, which is Jira. You can create an account there. Needs to go for an approval process, but if you just say, I'm asking for an account because I want to report a bug, then typically within a working day, somebody will approve that. I'm not making a guarantee here about this working day, but generally speaking. This would help us enormously in making Maven really worth a 4.0.0 without betas, without alphas, without milestone releases. And if you are okay with that, we'd love to have such a reproducer inside the test suite that we have for Maven. We have an integration test suite that runs close to 4,000 projects, I think, on every build. They're all green today, and we strive to keep it that way. But maybe your project has something that we did not foresee in any of those 4,000 cases. You wouldn't be the first one, trust me. And we'd love to add that into the test suite so that we can ensure it will keep on working.
Yes. And maybe I want to add to that, if you test it and it does work fine, also mention that, because currently we don't get a lot of reports and we don't know if the reason is that everything works as expected. That could be, of course. Or that there's nobody, would be great,
Yeah.
or just only a few people are testing it. So we really want to have better numbers to know the number of people that are testing Maven 4.
Yeah, that's a good one. You don't need a Jira account for that, by the way.
No.
You can just, I don't know, look us up on social media or find us here in the hallway or just send an email to the user list. It's all fine, but it's a good addition.
So
We know a few projects out there that do run Maven 4 builds every now and then, but there are not many. There are probably a handful or something.
yes. So we will be here for the rest of the week. It would be great. I'm pretty sure almost everybody has their laptop. Just download Maven 4. You probably have a couple of Java projects on your system. Give it a try.
And download Java 17 if you hadn't already.
Right.
With that, we'd like to thank you for staying here with us. We hope it was useful to you. Please let us know through the Devox app. There's a QR code on the back side of your badge. You can scan that. Let us know, was it useful to me? What could we improve? Or what should we definitely keep this way? If you want to play around with the demos, we've got a GitHub repository for you. You can access all the demos that we did, play around with them. And we have plenty of time left for any questions, not only about the last module, but basically about anything as long as it's Maven related.
There's a question over there.
You mentioned that the data model for Maven is now evil. Do you use extensions that modify things like the version, even though you not work? What is the alternative to have a process where you do not have specify the version in your project?
So your question is about the immutable model. I'm just repeating it so everybody is aware of what the question is. The immutable model, what if I have an extension or any other Maven component basically that does need to modify the model, right?
Yes.
Yeah. So I'm answering this from the top of my head. In a lot of scenarios, there will be a method to actually change it, but it will not be set whatever, but it will be with whatever, which will give you a new instance of the same class. And from there on, I am not 100% sure, because it lives there on in your code? How do you get it back into the project? And that is something I would need to look up in the documentation. I don't know it from heart. Do you happen
No.
to know from heart?
No, sorry.
Okay, well, that makes two of us. I'm sorry, this is not a complete answer,
No.
I do realize, but
That's also one of the reasons why we did want to mention it, because it can have a lot of impact, especially for extensions. They are really the way to manipulate things during the Maven build. So
Yeah.
yes, I'm pretty sure that there are some hooks to still be able to do that, because that's one of the reasons why there are extensions.
yeah. Any other questions? None, I guess.
Okay, maybe we should mention the. Oh, okay, first.
Yeah, when the consumer POM is generated, I'm not sure, but we are using our company parent POM. If that builds, finishes, it's rewritten with JGit for now, and it uses Maven to write the POM again.
Mm-hmm.
But the properties are all put in a hash map, I think. So the order of the properties is random, and it's hard to find and read the Maven properties when you click through to the POM, to the parent POM. So now the question is, will it preserve the properties in the order of the original file, or will it still be?
Okay, so the question is, there is a Maven plugin that you are using that is already kind of transforming the POM file, right?
To fill in the project version,
Yes.
to write it explicitly, so if we inherit from that parent POM, that project version is correct.
I think I'm not sure if you know the answer, but my answer would be, let's give it a try to just figure out what it is doing, and is it doing as expected? If not, let's discuss and make a couple of Jira issues for that.
For the plugin, of course, I don't know, but I think in the build consumer POM, we took quite a bit of care to
Yes.
to keep the order in which all elements are declared. And that also would include project
I don't think so.
properties. You don't think so? I
No.
think I
No.
might be wrong.
And the reason why I think this is interesting discussion on stage. So that was my original approach. Just
Yes,
to keep
I know.
everything as it is. But I think currently what is done is it is loaded into the Java model. And from there, it is being rewritten to an XML file, which means that you don't have the order anymore. I think. Sure. But what I expect is that dependencies go to the bottom, and so that might move. But the properties itself, I expect them to be in exactly the same order, in case. That map supports it, and I think we're going to use Java 17, and as far as I know, that should keep the order of entries by default.
It's hard to prove.
It's hard to prove. Yes,
in the sense that you don't know if it would have ordered.
Yes, I see
It
what you
would
mean.
have changed in order. So I was about to try it, but while doing it, I realized there's no guarantee that the order would have changed otherwise. So it doesn't make sense to try it out here.
No,
Never mind.
I think we should just give it a try.
Yeah.
Just make a small demo and give it a try. Any more questions? Over there. Performance. Do we have numbers about performance? I think a part of the performance you already get by going to Java 17, right?
Yes, I also recall that on quite a few places we now use the NIO rather than the old IO.
Mm-hmm.
And I know that one of the reasons that the build consumer POM separation was rewritten was that the earliest implementation, no offense on your end,
No.
it worked out pretty well, but not if you were building projects like Camel or Quarkus. And for your idea, these are large multi-module projects with roughly 1,000 modules in deep hierarchies. In such projects, we observed that reading the POM, transforming it, consumed quite a bit of memory and CPU, and that was, I think, one of the reasons, not the only one, that it was rewritten at least one time to get a more streaming approach. So we do take that into account, and if people can come up with a project like I think it was the Camel people that saw it first, and they could just show us, if we do it with Maven 3, it takes so much time. Maven 4, it takes, excuse me, not just a few seconds more, it was an order of magnitude bigger. So there was really a visible performance decrease on their project. So it's not something that we measure continuously, but if you have a project where you can illustrate the difference, it definitely gets investigated.
I have made some comparison between the different Maven versions and the performance about that.
Mm-hmm.
And you see at the moment a little bit difference between Maven 4, Beta 4, and the older Maven versions. So we have not reached that performance at the moment.
Okay, so the comment here in the front row is Maven. There's a subtle difference between Maven 4.0 Beta 4 and older versions. Is it better or worse?
At the moment it is a bit worse.
Slightly worse, yeah. But is it something you're worried about?
At the moment, no, because we are working continuously on the code at the moment, and we are not doing, from my perspective, performance optimization.
Yeah.
And focus on that.
I would agree with that. It's too early to do performance optimizations, unless we see like these really big differences. Then it's clearly something we need to investigate. Yes.
So clearly the separation of the build POM and consumer POM was the thing to solve. And after that, we can indeed have a look at performance, but it was not on top of the list. Sure. That's one for you.
For me.
I think it's a matter of downloading Maven 4.
Yeah, in all honesty, the best
Yes.
advice I can give you is this. If you go to maven.apache.org/download, you will see there's a section to download the latest free whatever. And there is already a download section for whatever. And that right now should list Maven 4 Beta 4 as the latest in the 4 series of releases.
I've seen that, but that's all there is.
Right.
I would have expected a little bit more.
Yes, I think I get it. So by just downloading it, we just want to make sure that current builds will still work. The next step is indeed, can I remove all these kinds of redundant information, etc. I think that part is not documented as good as we should have.
No. I think also one of the reasons is you don't have to. There's no need to rewrite your POM. You can do it, and there even exist tools that help you in automating this process. I'm not sure if Tim is still in the room. Yeah, he still is. He works for Open Rewrite, which is a tool that can actually help you in doing these kind of automated migrations. But because you do not need to, there's no official migration guide or something like that. If I may recall the second slide or the third that we had, the TLDR is your existing project still works.
Yes, I do understand, but you also have a request for feedback. So I would assume that at least within the
Yeah.
So
We'll probably include this one then. Maybe that already gives kind of a direction. Like, yes, you can use it. There may still be bugs, and we take those seriously. But please help us in finding, identifying, analyzing, and fixing them.
So as weird as it may sound, we expect no issues. Yes, you download it, you work with it, no issues. However, what you should be able to see is there will be a consumer POM and there will be a build POM.
Yeah, and then from there on, we could say, now that you are using Maven 4, here is things that you can change in your build.
Yes.
You don't have to, but you can.
But this is really what we did is the fundamentals of Maven 2 and 3, where the POM file was that only single file. We're now taking that apart and changing it, and that's so huge. It will open doors for a lot of new things. But we first need to be sure that this mechanism works, and hopefully you just work with Maven 4 and you won't notice it. Yes?
Special version of Artifactory or Nexus required?
No.
No. Repeat the question, please.
If there is a special version of Artifactory or Nexus or any Artifact repository required, and the answer is no. It will just upload both files, and depending on if the POM file should be used as a parent, it will switch to the build POM, otherwise it should use the consumer POM.
Right. I think we're going to wrap it up here.
Yes. I think there's one thing we should mention is that tonight there's a buff session.
Yes, very good.
So in case you're still struggling with the question and you just don't know how to ask it or whatever, or you're just interested in other discussions about Maven, Carl Heijs will be there. We will join there as well.
Yep.
It's around 7, I think.
7:05.
Ooh, so if you're there at 7, you're too early. Oh, okay. Well, let's stand in front of the door. Okay. I hope to see you there. Otherwise, have a nice conference. Thank you.